Okay, so I'm going to show us how to be able to visualize the output of Roary-Pangenome analysis in genomics. It's quite a little bit of an issue to some people. So let me share my screen. My screen is already sharing, so I'm just going to pull up my some few things here. So if you check, these are some. Okay, so I just call this Roary results. If you check where my cursor is blinking, you can see I have Roary results here. And so when you run Roary, then it's going to bring out a lot of files. And then some of the files, as you can see them around here, let me highlight all of them. As you can see, there are various ways through which you can visualize some of these files. So I'm just going to show you one of them using R or R programming. Now, one of the most important files that we know that Roary produces is the gene presence and absence data. So you can see one of it here. It comes in the form of Excel. You can also have another one which also comes in the form of what? R-tab. So we can actually go to RStudio and see how we are able to import this particular R-tab file, and then we visualize it so that we can see the strains as well as their wherever the genes are present and the genes are absent, then we can see it. So let's go to RStudio and do this as quickly as possible. So we're in RStudio now, and so not to waste your time, I've already put up the script, but I'm going to be explaining them alongside. So at the moment, I'm just going to use this way of importing. I could have used any of the I could have used over here one of the panels, this particular environment panel. Then I could use the import data set from here, and I could import it there. So here I can just use file dot whatsoever, and then I'll just go there and go and import it, and then that's all. But before I do that, let me say that if you just import the data, just say the R tab directly into this particular place, it's going to give you a little bit of a problem, because the way the R tab data is formatted is a little bit different. So to be on the safer side, why don't you just go there? You see how it is. Then you can open it with your. So this is how it is. So actually the first column is the gene, and of course these are the strains, and then it has produced, wherever you see 1, it means the gene is present. When you see 0, it means the gene is absent. So we need to visualize this to be able to, if not, you can't make sense from all this 1 0 1 0, but these are the genes. So to be able to do that, so what I normally do, I just Control A to highlight the whole thing, then I copy it, then take it to Excel. I can just open Excel, a new book. I can just open a new book like this. Then I'll just come there, and then place it over here. I'll come and paste it over here, and you see that it is pasted. So now I can save it. I can simply just save it as a comma separated, let's say a comma separated values, like CSV file. So when I come here, I can just do, I'm going to save it. Then let's say I'm going to save it in my, in my document. And so when I come here, I can just give it a name, but I'm going to use comma separated values. But let me remind you, the comma separated values, they are different type. We have one for UTF. It's also comma separated, but this is for if you are using Ubuntu operating system. So you also have one for Mac if you are using a MacBook, and if you will have some for Microsoft. So we see the Microsoft, I have highlighted it here, so I just click on that. Then I give it a name. The name already is gene presence, let's say presence underscore, and then absence, right? Gene presence and absence. So that's how it is. So I can just click save, and it is saved on my document. So but they are saying that I've already saved one of the files there. I just wanted to show us the processes. So I could just add here, I could just say maybe I'll just put that place 2, and then when I do that, it is saved. Now it is found in my documents. So now let me go to my RStudio. When I go to my RStudio, I can just use this small thing. So I'm going to I just created a variable here. So I'm saying that this particular variable means what is it, micro or mycobacteria fortuitum, gene presence and absence. So, and I just say read.csv file choose. So that way, when I run this particular line, it's going to take me to my, all right. So I can now go to my documents. So if I go to my documents now, I can just check for my documents on my computer, and then I have my documents around here. So if I go through my documents, I can see gene presence and absence too, which is here. Then I'll just come and click open, and then it is there. So now it is found in this particular variable here. If I should do a head, so if I do a head now, you can see that I actually have the data has been imported and it's now sitting on my local, or it's now sitting in my R environment. So I can just look at the class of the data, and you can see that it's a data frame. But it's always important to know whether the data, there are some NAs or not available or something like that. So to do that, just do summary, and then if I do a summary of MF GPA, and then so if I see that all the summary of all the variables come, then I know that I don't have NA anywhere. If I were having NA, you wouldn't have seen this minimum, first quartile, median, mean, and whatsoever. The 5, you won't see them. That will not come. So it means that my data is clean. So I can go ahead with the analysis. Now, let me go back to my RStudio here. Then when I come here, there is something I need to tell you. To be able to visualize it, let's say that I want to produce a heat map. But a heat map, I can't do it with the X side being non-numeric. So I have to make sure that all the numbers or all the variables there are numeric or integers or numbers. That way, I'll be able to visualize it. So how do I do that? But if I also look at the structure of the data, then you will notice that some of them are characters. So let me say I want to look at the structure of the data. So if I come here and I say my MFGPA, if I look at it, you will see that, the first one is a character. So once this one is there, I won't be able to, to be able to visualize it if I'm going to use a heat map. So what will I do? But I want to also make sure that the heat map has labels. You see, it has to have labels. So what will I do? One of the things we do in this kind of analysis is to make sure that the gene, that particular column, we make it an index column, right? We make it an index column. So the index column is very simple. To be able to do an index column, it means that you are going to make sure that that particular column is not part of the main column, but is part of the data set. All right. So arrow would exclude those ones and see them as names. So what names are they? They are going to form our row names. And that's why I am using this particular code here, row names. Then you put into bracket the data frame that you have. And then the same data frame again. And then you pick only, the variable that you don't want it to be part of the entire data frame. You want to make it an index column. So I want the gene column to be indexed. So if I run this, then it becomes an index. So another way of doing it, this is the easiest way that I could have done. So for instance, where am I? Around here, I could have just said that I'm just reading straight. So this particular long code you have here, I say read.csv file, and then I put in one quotation marks the name of the file, which is a CSV file, and then I'll just go there and say that row names should be equal to one of the columns, and the column is only what, gene. So when you do that, it becomes very easy for you to be able to visualize. So now let me show you how that is going to be done. So I just go straight. But how do you get this particular row name? So I'm going back to my environment, to my documents here. This was then I look for the gene presence absence here. Then you right click on this, click on name, just copy and then Control C. It has copied the name there. Now get back to RStudio. Then you just come highlight from this portion up to this without the CSV and without the dot. And then place it. It will be there. Then when you run this, alright, so let me just correct the error here. We are saying that the error in file cannot open the connection in addition warning message. Okay, so I'm going to close it and then I'll do it again. So I'll just come to, I think the file is open around here. So what I'm going to do, I'm going to close it from here, and that is it. Then I go back to RStudio, then run it again. Okay, and then the error still persists. So I think it might be from this one. So I could actually just copy the entire thing here. I think there might be a space around here. Okay, so I'll leave it around here. Then I go back to this environment. Then let me just come to my desktop. Then I pick a different file from there, which is they are the same. So this one will be quickly. Okay, it is here. So name, and then I just copy it. Then I go to RStudio. Just going to come here, and then I'll place it there. Try and see if I can run it. Yeah, that ran properly. All right. So because that one was already in what is it in it. So another way of also making sure that you make sure the gene column is free is to run this. You just put the data frame, select that particular gene column, and then run it with null. Then it will make it empty. All right. So now when you come here, now that I have run this particular line, it means I have taken the gene column out of the entire column. So if I now come and do a structure, if I do the structure of the same data sets, the MFGPH, like this, then you will notice that we don't have character again. You see that all of them are now integers. So we are now good to go. So what is the next thing to do? You cannot visualize this kind of data in in data frame format. So you have to convert it into matrix, because we are going to visualize it in heat map. So we have to convert it to matrix. So we created a new variable, and we say that to convert it to matrix, you just use this as matrix. Then if I run that, it means the data is no more in data frame form, but now in the matrix form. If you want to know, I can just come here, you do class. Okay, you have class here, then put GPA. I just created that new variable because I still want to keep the data frame and then keep the matrix data so that I can visualize. So you see that now it tells me that it is a matrix and array. All right, so now once it is now a matrix, then it's good to go. We can now visualize it. But here let me say that to be able to visualize this kind of data, you need to make space for where the figure is going to appear, because it's a large data set. So the file pan, you have to make sure that you widen it up. So you see that I'm widening it up to make sure there's more space. Now I can just run here now, say heat map, without adding anything to it. I can just run it and then the heat map will be generated. But for the sake of time, let me do it this way. So to run the heat map, the syntax is the first argument is your data, and now our data in the matrix form is the GPA, that's gene presence and absence. Now when we come here, we say column variable. Do we want the heat map to produce let's say a clustering on the columns? If it is true, then we say yes. What about on the row side? Do we want to produce another let's say clustering from that side? If it is yes, then we also say T. If not, you say no. Then the scale is going to be columns. All right, I can add color and whatsoever to it. So but let me run any of this. If I run this line, I'll have heat map. If I run the second one too, I'll also have heat map. So if I run the first line, it means that I am saying that heat map should put all any variable at all by default. And so that's what happens. So that one, there's no user specification. So because I said it's a large data set, so it's going to take a little while before. So you can see that they are saying that error allocate vector of size 1.9 gig. So it's really very heavy and it's finding it difficult to be able to produce it. It takes time before it will be able to produce. So let me run it again. So it's a little bit heavy, that's why we are not seeing it. Let me see if I can make some space small, delete some variables, and we try and then visualize it again. But if you check, I've already done the visualization. Let me just pull up here. You can see that's actually the heat map around here. I just wanted to show you the space of how it is being visualized. So now the samples are here, the genes are over there, the clustering is on top. That's column clustering. That's clustering of the variables, the samples, and then clustering of the genes, which are also here. And then these are the heats. What the dark colors means that the genes are concentrated over there. The light shaded means the genes are not there. And of course, or they are there, but not as much as compared to where we have the dark shade. The white shade means that the genes are just absent. And so that's how, we're able to visualize it. And get back to R Studio. So at this point, what is happening is R is unable to generate the heat map because the vector, the output is going to be around 1.9 gigabytes, as you can see it around here. And R finds it difficult to be able to allocate a vector of that size. That's the reason why I'm not able to, but I had already done it. So this is the processes you follow to be able to generate your heat map, or to be able to visualize your gene presence and absence data in the Roary output. The other ones I will do it in the subsequent videos, and then that will also be available. Thank you, those of you who are watching. Thanks.